All right, so in this video, we're talking about AI, specifically the Vercel AI SDK. The version 4.0 is released, and there are a ton of cool new features added every day. I'm joined by Nico from the AI SDK team. So Nico, thank you for joining me on this session.
Happy to be here.
Awesome. So we want to cover some basics to just create some common grounds of different terms that you would hear in the AI world and different models you can use, prompting and whatnot. Then we'll jump into the AI SDK, give some examples of creating a chatbot really quickly, but then extend it with tools, which is really interesting. The new schemas and the new functionality that folks have added to the AI SDK. Here makes it really easy to just take a simple AI chatbot way further. If you have time, we may also look into PDF support, or at least we would mention it, or maybe we follow this up with a second series. So there's a lot to cover. But before we jump into the AI and the SDK and all that, Nico, why don't you tell us a bit about yourself, what you do now, and how you got into this world of AI? What are you working on day to day? And then we would just jump into your thing.
Absolutely. Well, again, thanks for having me here. So my name's Nico. You can find me on Twitter or X or Blue Sky or any of these places at Nico Albanese 10. And I have been at Versel for a little under a year now, working on the AI SDK. And before that, I had kind of a non-traditional entry to this space. I actually I grew up wanting to be a professional football player. I'm from London. I'm from the UK. Wanted to be a professional football player. Hurt myself, which at the time was not great, but was the greatest thing that has, in retrospect, ever happened to me. Ended up going off to school to study business and went into venture capital, of all things. Worked at an early stage pre-seed fund, investing in really exciting businesses at the intersection of tech and creativity. But funnily enough, I've been programming ever since I was a kid. I really have loved Apple and in particular quite an Apple fanboy. And I remember, like many, the really incredible moment when the iPhone was first announced. And I wanted one more than anything, but I knew that I was never going to be able to afford one. Thankfully, I had access to a Mac, and I found out about the developer tools, and in particular the simulator, so you could have this iPhone on your computer. And so I downloaded the whole SDK, and that kind of led to, okay, I've got this working simulator on my computer, but it's got no apps on it. And that introduced me to Xcode and building apps from a pretty young age. I think I was 8 or 9 at the time, and
Wow.
learned just by like YouTube tutorials and going through documentation, a little bit of Objective-C, started just making ideas that I had from school projects all the way through to little games, and even went through deploying and getting things on the App Store. And so from, I guess, that early age, I had almost no barrier in terms of, oh, I've got an idea, let me make an app on my computer for it and put it up on the App Store, and Apple manages all of the distribution and all that kind of stuff. Anyway, this was all the preamble to saying that at my last job, I started seeing issues that were frustrating in terms of our daily process of managing the fund. And I started having ideas of how we could build mini apps to be able to scale and automate these things. And so that led me to building a few little websites here and there. And I actually discovered Next.js in that time. That was probably 5 or 6 years ago. Started building some little Next.js applications to automate how we were reviewing inbound deal flow and automate how we were communicating with investors and that kind of thing. And this just led me to building a lot, going from this idea of having an idea on a weekend and iterating until I had something that solved my own problem. I ended up quitting that job because I wanted to turn those mini apps into a little business. And funny enough, in the process of building out all of those mini apps, I ran into this problem around building Next.js apps where building out the infrastructure was really frustrating, like setting up your ORM, setting up payments, setting up authentication and all that kind of stuff. So I built an open source library that helped scaffold that infrastructure for your application. And then it also was inspired by Ruby on Rails. So it allowed you to define your underlying data structure that you wanted. And then it would scaffold like database schemas, your API routes, server actions, and ShadCN pages and all that kind of stuff. And anyway, that kind of got me in front of Versel, and one thing led to another, and I joined about 8 or 9 months ago to work on the AI SDK. And my title is a DX engineer, but really that means anything that can help others, empower others to build great applications with the SDK. So that can be anything from working on documentation to building examples, building templates, and so on.
Really, really interesting, the journey that you had to here. Let's backtrack. What was the open source framework or the library you worked on for scaffolding XJ?
Yeah, so it still is called Kiramase. And there's a funny story actually from that name where I had seen.
I know that. Oh my God. My God, you can't believe it's one of the topics that I want to cover because I came across that. And now I remember I also actually saw a video of you talking about the name and that it's just kind of a funny version. Oh my God, I can't believe you're that same dude. Oh my God. Okay, continue. So what was the name story there?
So the name was Kiramase, and I don't remember where I was. I was on holiday at the time and working on just this idea because I was really obsessed with the pain around installing these things. But in the JavaScript ecosystem, as you would know, there are a lot of libraries that have Japanese names like Jotai, and others like that. And I thought that was so cool. And I love Japanese culture and everything Japanese. So I was like, all right, what is this doing? And at the core, this was meant to be like the equivalent of NPX Prisma init, but for Drizzle. That was how it all started because I really enjoyed using Drizzle. And so I went into Google Translate on my phone and looked up Drizzle and saw Kiramase. I was like, oh, this is sick. That sounds so good. And so I went onto NPM. I looked it up, searched it, and there was nothing. There were no websites. There were only like 10,000 results on Google. So I was like, man, I've hit the jackpot. So I ended up launching it. And somebody asked me where the name came from because I'd never heard of it. And I went to Google Translate to show them. And I typed in Drizzle and it came up Kirasame, which is obviously quite different. And equally, when you look up Kirasame, it has like 1 million search results. And I think there's an NPM package or something. So anyway, it ended up being quite a good story.
That's really interesting, man. It's whoa, what a full circle here. Because I remember I came across that tool a little while ago, and I saw it was interesting. You could scaffold. You could basically go through in the terminal, say, do you want to use Clerk as your authentication or NextAuth? Do you want to use Prisma or Drizzle, or do you want to use this database or that database? And then it literally just spins up everything that you need to do instead of you having to create this template or the starting point of every project. It's still in my notes and I wanted to cover it in a video, but like I get different projects and everything that I want to cover that I found interesting, it just gets pushed down the list. But I remember I actually saw a video. Now the picture came to me that it was you, because when I was listening to you or seeing like a video on AI from Vercel, I always thought, how do I know this guy? He looks very familiar, but it's assumed it's the AI stuff that I have seen, nothing else. So very interesting. So maybe we cover that in a video too.
Yeah. It's I have a big rewrite that's coming up soon that I was actually focusing on for the hackathon, but it is the cooler part of that project is actually not the initial instantiation of the project, but it's like based on the Ruby on Rails scaffolding of resources where you can it builds on this assumption that UIs are a function of the data that they represent. And so if you know what that looks like, you can be very deterministic with defining the back end portion of the application and kind of let people experiment on the front end. So I consider it almost like the ShadCN of like full source applications, because it punches out everything that you need, but with no abstraction. So you can kind of edit it to your heart's content.
Very interesting, man. So maybe instead of me covering that, I will just have you on.
So yeah,
way easier. All right, awesome. That was interesting. I didn't know that. And another thing that stood out to me from your journey, because I have a similar journey in that I don't come from computer science. I didn't start programming as young as you were, but like I come from actually also business background. I studied engineering, but somehow stumbled on web development and programming, and I was like, man, I should have started this way sooner. It's a newly found still passion for me, but it's very interesting. You also mentioned you play soccer. By football you mean soccer in London,
correct.
Right? Because yeah, all right, because we call it football as well. back home, but now here football is like the American football, which is not soccer. So what is your favorite team down there in UK?
It is unfortunately the Arsenal. I have been a fan since I was a kid, and I became a fan to spite my best friend, and he was a Chelsea fan, and it's led to like 15 years of depression for me, and he's run the Champions League twice and the Premier League and all of that. So I clearly lost that side of things.
All right, very interesting, very interesting. All right, so good stuff. Shall we dive into some AI?
Let's do it. Yeah. So
All right.
as you had kind of given the background, I want to start with a bit of a leveler in terms of like I want to make sure that everybody's on the same page with a few core concepts, because I think you can't say AI without hype in a lot of things. And so as a result, I think most people, particularly that would be watching, have used some kind of chatbot or are familiar with language models, but it's always helpful to dive in and set kind of core assumptions across everything. So I have a few slides. I know slides are very boring, but I have a few slides that should introduce some of these concepts, or at least set the foundation, and then we can dive into some examples as well.
Absolutely. Take it away.
So let me share my screen. No, rehearse is not green. How's that? Can you see the slides there? Perfect. All right. So the idea in the next couple slides is that we're going to cover three main things. We're going to cover a very, very high level introduction to large language models. Again, I want to preface very high level. We're then going to go over a bit of an introduction to prompting. And then finally, we'll give an introduction to the SDK. So starting with language models. What are language models? Well, large language models, or as I will abbreviate for the sake of brevity, LLMs, predict text at the end of the day. Now, that's obviously a gross oversimplification, but it's a really important point to remember. These models are trained on an enormous quantity of text to be able to understand and generalize patterns in human language. So simply put, an LLM can take an input and spit out a word or a token that is most likely to follow it. So in this case, in this example, when I hear rain on my roof, I blank in my kitchen. A language model would go through and take the most likely tokens to fill that space and then return them with some level of probabilities. So in this case, when I hear rain on my roof, I cook soup in my kitchen. Now, the text that LLMs are trained on often includes instructions, and as a result, these models can start to identify patterns not only in language, but also patterns associated with following instructions. And in this way, I want you to think of language models not only as text generators, but as information processors. And this is really powerful, as we'll see in how we're going to be using them to build applications. So something to keep in mind in general, and as you're thinking about using language models in the concept of building applications, LLMs are just an API. And what I mean by this is don't overthink it. Don't think you need to completely re-engineer your application on a new framework or a new whatever. In most cases, you're going to be interacting with a language model via a hosted API link. And so treat it just like you would any other API. Obviously, with a few caveats that we're going to go into in a second. So, as I said, that was a very high level introduction to language models. But as we go through things, I really want you to remember this idea of language models identify patterns. Just remember patterns, patterns, patterns. So, prompting 101. Why are we even talking about prompting? I love this meme. Prompt engineering is just English grammar. Change my mind. The title prompt engineer has obviously become a bit of a meme at this point, but I really cannot overstate the importance of it. And the analogy that I often use here is thinking of a chef trying to cook a meal with bad ingredients. I think everyone would expect that it's fairly likely that that chef will likely end up with a bad plate or a bad final product. It's the same with interacting with a language model. A bad prompt is likely going to lead with a bad output. We've got to start with the right foundation. And the reason we're talking about this is that clear communication is hard. I often joke about one of the things that language models have introduced or has brought to the surface is how badly most of us are at communicating. And this is really showing that. And this is likely the reason you hear some people saying that ChatGPT is useless and other people saying it's completely changed their life. This is a tool, and like any tool, you need to be really intentional with how you use it. So how can we be intentional? Well, let's start by looking at what a good prompt looks like. So a good prompt will likely have instruction. This is a clear articulation of the task you want to complete. Context, this is any relevant information to the task or input data that will follow. The input data, this is the actual information the model is going to use to complete the task. And finally, the output indicator. This is exactly what you want the model to return. Now, this may sound a little bit abstract, so let's tie this into a real example. Let's say you have an academic paper that you want a language model to summarize the main point of. The instruction would be, please analyze the given text and identify the main argument. The context would be anything about the paper or input data that's following. So this academic paper is about climate change, and the audience are primarily environmental scientists and policymakers. The input data is the essay or academic paper itself. And finally, the output indicator, really important, is exactly what you want the model's output to actually be. So in this case, a single sentence summarizing the main argument. And in many cases, if you think back to using a language model, using a ChatGPT or a Claude in your own personal life, if you've ever struggled to get it to do what you want it to do, it's likely that you've missed out on one of these points. So let's look at a few prompting techniques that you can use to try and get the best possible generations. First, we have zero-shot prompting. This is just a really fancy way of asking the model to do something without actually giving it any examples of what you want. This works well for simple tasks, but note that this relies heavily on the model's pre-trained knowledge. So in this example, we could ask the model to classify the sentiment of a statement, and the model might return neutral. But what about for more complex tasks? Remember that these models are trained on a vast amount of information to generalize patterns in language. And as such, they're very good at following instructions. So for more complicated tasks, we can vastly improve the generations we want by providing examples. So that's where few-shot prompting comes in. With few-shot prompting, you're literally describing similar situations to give the model an indication of exactly what you want it to do. In this kind of bizarre example that we'll gloss over the exact content of, but if you look on the right of the slide, you'll see that we have a definition label, and then we have a definition of, in this case, a fictional word, and then we have a label that says example, and then we have that word being used in its context correctly, big quote unquote. Then we have another fictional word attached with that definition label. And finally, we have the example label, and we're prompting the model to complete that pattern. So in this case, the model might respond, when we won, we started to fardaddle in celebration. Again, the content here isn't important. What's important here is that we've given the model a pattern and effectively literally prompted it to complete that pattern by giving it an incomplete version of a pattern. I'm saying pattern a lot. We should have a pattern meter in the count meter in the bottom left corner.
Absolutely. Yeah.
Few-shot prompting can be super effective with more complex tasks, but as with everything that I will go through and everyone will ever tell you to do with AI, play around with it, experiment, and iterate. There is no right way of doing things. If anyone says there's a right way of doing things, they're wrong. We're still understanding these things. So as with anything, iterate and experiment. Cool.
One question that came to my mind,
of course.
I'm jumping in, is when you talk about this few-shot approach where we're defining or giving examples of the definitions and examples, and then kind of leaving the second definition and example empty, or give the definition and example empty. The first question that came to my mind is that, which you kind of answered, but I want to just reiterate on it, is that, is there a specific syntax or pattern that we should use for providing these few-shot examples? Now, this might be in that you're giving a pattern for the model to follow, or you're giving it a schema or a specific way that you wanted the response to be returned. I'm assuming, as you mentioned, there's no right or wrong way. You just have to test and try and see what works. Some of the tools in the AI SDK is going to help you give some structure to the response that you want. But I'm curious to hear your take on, is there a specific way or syntax that we can use to clarify these examples you're providing for the model?
That is a great question. So yes, as you kind of answered yourself, there is no like necessarily right example or right approach. I would say one approach that is used very heavily, and like I would say used also very heavily in V0, a product that we build at Vercel, is using XML syntax. So you kind of, in the same way like as with JSX tags, you would start with opening arrow and then have like a label and then kind of closing arrow there, and then you would put whatever relevant content between those tags. It's a really popular way of providing information or patterns to a model. It's a way that it understands very well. And we've actually seen in like leaked prompts from Claude and from, I think, from OpenAI and other like big AI products that they rely heavily on XML tags as an effective way of prompting a model in this way.
Interesting. Awesome.
Cool. So so we'll jump through that. Cool animation, I would say. We'll jump to the final prompting technique that we're going to go through, which is called chain of thought. And I really like chain of thought because one, it's a much more simple and easy to understand name than zero shot and few shot, but also because it mimics the way that we as humans approach thinking and reasoning on complex tasks. And that is that we take a complex task, break it down into smaller intermediate steps, thus creating a chain of thought that eventually leads to an answer. And this pairs really, really well with few shot prompting, i.e. taking like a similar complex task, breaking it down into the intermediate steps to get to a final answer. And that's what we see in this example on the right here. So this is hard for me to explain, let alone like kind of reason in this exact example, which is giving the model a bunch of random numbers, telling it to pull out the odd numbers and asking if the odd numbers add up to an even number. So a little bit like confusing to wrap your head around, and something that a model with no examples would really, really struggle with. But instead, in this case, if we give it that similar example before, where we're saying, okay, do the following odd numbers add to even, 4, 8, 9, 15, 12, 1, we write reasoning as a label. Obviously, reasoning in big air quotes here because we're kind of fabricating this here. But then we say odd numbers, we pull them out, 9, 15, 1, and then we literally write sum to 25. And finally, we add an answer at the end to say false. In this case, as we did in the few shot example, we prepare what is the question we actually want the model to answer, and we provide the reasoning label, but then we leave the rest blank, thus prompting the model to mimic that pattern, but with the new context. So in this case, it would go through and pull out the odd numbers, calculate that they sum up to 41, and thus answer false. They do not add to even. So this is a niche example, of course, but shows you how you can manipulate the model a little bit, or manipulate is maybe strong. You can steer the model in a direction that you want by giving it a pattern of instructions that you want it to follow. So this technique is really, really popular. There is a shortcut to this technique, which is what they call zero shot chain of thought, where you just kind of tell the model to think step by step, and it forces the model, not forces, but it prompts the model to go through this process of first reasoning about what are the necessary tasks to complete to get to a final answer. But I think in many cases where you can, a great example will always be your best approach to getting the outcome that you want. Cool. So I'm a broken record here, but try things and iterate with the speed at which these models are improving as well. Different models behave very differently. So something that might work with GPT 4.0 mini might not work with 4.0, but also might not work with Sonnet 3.5 or Haiku or whatever it may be. So you really want to, your prompts are these really malleable strings that need a lot of attention, and they need a lot of iteration, not only to get to something that's working, but a continuous effort to keep them effective. And we won't go into this today, but this is where like you would start to think about evals and how they influence how you can add some level of determinism to what is fundamentally non-deterministic and difficult to predict. Again, another like tip here, language is nuance, and literally one word can completely change the output you get. An example of this is like if you've got a code, a chatbot that's creating code somewhere, the word add versus the word create can literally lead to the model appending information to a file that doesn't exist, or actually going through the process of creating. So language is really, really powerful here. And then the very last point, this may sound a little bit negative, but be realistic with your prompts. And what I mean by this is, don't expect the model to create the next Facebook by literally writing, please create Facebook. Like you've got to approach it almost like a really intelligent intern that's next to you, but that doesn't really have any context. So anything that you don't provide will be implied by the model. And that is actually foreshadowing into my next slide, which is be specific and over-explain, because anything you don't explain will be inferred by the model. This isn't necessarily a bad thing, but it likely will lead to the model not doing what you want it to do, because it will be assuming based on the training data that it has, that obviously is not something you're necessarily aware of. My final point to bring this point home in particular is an anecdote from a movie of mine that I like very much, where Will Ferrell is a race car mechanic on a race car team, and he's asked to fill in for the main driver. He somehow wins his first race, and in the podium interview afterwards, he keeps lifting his hands up above his head. Now, you and I might say, okay, we're going on TV, don't lift your hands up, but nobody's told him not to. And so he doesn't know what to do with them. And so it's the same thing with language models. You really have to be clear with what you want it to do. All right. We got through that. Now on to the AI SDK. And we can't tell the story of the AI SDK without first telling the story of V0. If you haven't heard of V0, we've been building it for about a year, and it's an incredible tool that allows you to build and iterate on applications with just natural language. But in building V0, we faced some challenges. And most of these challenges were associated with what was a nascent tooling ecosystem at the time. And to be fair, still is to this day. The first point was that the primary way of interacting with language models was via the library of the model provider. And these libraries are incredible. But naturally, with state-of-the-art models coming out every couple of months, and at one point in every couple of weeks, we didn't want to have to rewrite our entire application just to test how good a new model could be at our specific task. And additionally, as we were building out our application, we also saw opportunities to pair models from different providers together for different tasks within our application. So one very cheap, fast model would be great for like classifying user intent, where another more expensive, slower one might be more important for code generation or design or mimicking thinking, whatever that may be. Second, tooling was primarily Python and backend first, and this makes sense as all of the research for these models was done in Python. But naturally, as the creators and maintainers of Next.js, we wanted a solution that was designed for the ground up for JavaScript and TypeScript and was fully compatible with any Node.js environment. And the final point, which is probably the most important point here, there was no UI solution. And what I mean here is that AI brings a number of new challenges like streaming and non-deterministic outputs that we haven't really had to face before. This means that we don't know exactly what the model is going to give us, and we don't know how much of it we're going to get in every chunk. So that led us to building the AI SDK. And we call the AI SDK a TypeScript toolkit for building AI applications. So the AI SDK provides a unified API, so you can call any large language model from any provider. It's TypeScript first, although it works great with plain JavaScript too, and it runs in any Node.js environment. And it's fully compatible across all major UI frameworks like Next.js, Svelte, Nuxt, and more. Now, I had to have one slide full of acronyms. This is my favorite slide in the whole presentation, and that is the AI SDK is like an ORM for LLMs. Now, we don't have to go through all of those acronyms, but what this means is that you get to write your AI logic once, and you can change between providers with just one line of code. Now, speaking of ORMs, one of my favorite ORMs, Drizzle, has a great tagline that is, if you know SQL, you know Drizzle. Well, I think the AI SDK has been designed in such a way that we can say, if you know English, you know AI. Now, I know that's a bold claim to say, but I'd like to check out like a quick example to show you what I mean. So let's think about how we would call a language model in English. We'd first tell the model what we want it to do, generate text. We'd then pick the model we want to use. So let's say OpenAI's GPT. And finally, we'd tell it what we actually want it to do. We'd give it the prompt. So something like tell me a joke. Let's look at how this looks with the AI SDK. As you can see, it's almost identical to how it was in English. And remember how I said we could switch between model providers with just one line of code? This is how we would use Google's Gemini Pro instead. Now, obviously, this is a very simple example with just a prompt, but as we look at more complex examples with tools, with structured object creation, this becomes super powerful, being able to change just that one single line of code. But what about streaming? Isn't that what all the cool products are doing right now? Well, to change to streaming text, we would literally change the function from generate text to stream text. And because the stream is opening up immediately, we no longer need to await the call. So we can just say stream text. Now, believe it or not, with that, you've actually seen half of the core API. The other half of the API allows you to stream structured data. That is, force the model to return data that fits a predefined schema. In this way, your decision of what function to use comes down to two questions. What kind of output do I want? Text or structured data? And how do I want it delivered? All at once or streamed incrementally? All right, now we are ready to, we're finally over the slides and we can get to building. So any questions on any of that before we go into?
I think no question popped in my mind other than something that I will probably ask you later on, and that is, how do you know which model is good for what? You covered how easy it is to switch the models. I know in the SDK documentation, there's a section about different models and what the capabilities are. But I was wondering, when you are kind of trying to glue these different models together to get the outcome that you want and thinking about them, as you put, just like an API call, how would you know which model is good for what?
So my example is going to be very kind of like cop out here, which is like experiment is my biggest thing. I think I usually start with an approach of going as cheap of a model as I can to start off with for a very interesting reason. One, like you waste a lot less money as you're iterating on your prompt. But two, you're optimizing very heavily at the beginning of your prompting process to get to something that will work, where you might, if you were starting, let's say you're starting with O1 or Sonnet 3.5 or something like that. Those are very capable models. So the amount of information that you may need to provide in your prompt might be less than that you would need in a cheaper model. And so you kind of over optimize in the first place to building something or to writing prompts that you know are going to perform well.
Yeah, better. Yeah.
That makes sense. And then, sorry, to answer the last thing is like, we do on the SDK, on our doc site, we have on the providers page, we show which models are capable of doing what. For the most part, across like general, like structured object creation, structured object streaming, all that kind of stuff, I wouldn't say there's parity across all providers, but across major providers, you're looking at very similar core capabilities, and things start
Mhm.
to diverge when we're looking at more specialized capabilities like file inputs, like audio inputs, like that kind of stuff.
Makes sense. All right.
Coolio. So in terms of building, I thought we could take an example project that I have gone through a few times before on different live streams before. So it's part of a broader set of teaching materials in case people want to go through it later. But this example that we're going to focus on is using the AI SDK in just a normal Node.js environment, kind of similar that you might do if you were using it in a GitHub action or something like that, to take in some input data. In this case, we're going to take in some support requests, and these support requests are going to be that of like a SaaS company. And then we'll ask the model to do something with it. In this case, we're going to want them to the model to classify it so we can do something with it afterwards.
Amazing.
I'm going to set up a project very quickly. I'm going to share my full screen for this, which is always scary. Let me go through all of this. Let's see if I can do this without sharing API keys. This is going to be the
main objective.
Yeah,
exactly.
exactly.
It happens, for me, recording. Sometimes I catch myself after in the edits and I'm like, oh. And as you mentioned, the scary part is like when you go entire screen, then it's just like full blown out of control. So I feel the concern there.
Exactly. So what we've got here is this site right here, build AI app, December24.Vercel.app. So if you do at home want to follow along, this is intended to be done in a live environment, so it's not fully documented, but you can use it afterwards. So I'm going to head into my editor, jump into a terminal, make a new directory, and
While
then
you're setting that up, we're going to include a link to this live site in the description so you can access it. It's amazing. I've gone through it. There's different examples, and literally it walks you through setting your project up, and it has I believe 3 different categories of examples that you can go through, which is interesting. However much we can cover here with Nico, we can, but then you can just take it further on your own. So we'd include links to this.
Exactly right. So what I've been doing is just installing the packages, the basic packages here. And what this starter repo is a Next.js application that we'll be using as kind of the shell for both our terminal program that we're going to make right now, as well as a chatbot that we're going to make shortly too. So this next part I'm going to do off screen, but that is adding your environment variable in here. So let's see if I can do this without sharing everything. I think I'm done. I'm not sharing my screen anymore. Yeah. Okay.
Yeah. No.
I always got to check this.
Yeah.
I've done it too many times.
I'll keep an eye on it for you.
Perfect.
I have created so many API keys and deleted them after just to be safe. But then sometimes you don't realize what you've done, and later on you're reviewing it and you're like, oh, I didn't even realize what I was doing there. And it's not always like the API keys that's obvious, but it's like more subtle stuff.
Yeah, absolutely. The worst part with all of these is when you don't know the name of the API, so you don't know which one to cancel. That is problematic. So I think we are good to go now. Let's see. I think I'm good. I'd be very proud of myself if I get this all. All right, screen are sharing. Let's go. Entire screen. Here we are. Sorry for that, folks. All right. So let me get to the right tab. So as I said, we are going to be focusing on an example that has to do with classification. There are a number of tasks that language models are great at. You've probably used it a lot in a chatbot format where you're asking the model to do something. But when we move to a programmatic context, we can be quite deliberate and articulate with exactly the small task that we want a model to do. So we like to separate those abilities into maybe 4 definitions. So extraction, pulling information out, a classification, classifying some kind of piece of unstructured information, summarization, summarizing a piece of information, And then finally, like the question and answering, like more chatbot, continuous, fluid conversation without necessarily like a structured output. So we're going to start on classification. And what I've got here are a number of support requests. These have been generated with AI, obviously, and these support requests are meant to mimic that of a SaaS company. So these are things like, I'm having trouble logging into my account. Can you please assist? The export feature isn't working correctly, and so on. We've got about 7 of these here. In this same directory, we have a file called classification. And what's happening here is that we are importing .env.config. This is just to be able to pull in our environment secrets. And then we are pulling in those support requests under the variable support requests. And then we are logging the first 2 of them to the console. So if we were to run this, we should see, if I can spell correctly, the first 2 elements here in the console. So this, what we want to do here is a very cool use case, because this is something that we have in production at Vercel, and specifically on the Next.js repo. And shout out to Sam Coe on the Next.js team who built this feature, this mini app, we can call it. And what they have is that Next.js, being a framework that's downloaded over 5 million times a week, has a number of GitHub issues that are being opened every hour, every single day. And with a small team, it's hard to be able to go through all of them, understand what's important, what's not, what is a priority and what isn't. And so this is a great environment to test and use AI to classify these unstructured pieces of text data based on a predefined schema that you may have. So in our case, we define for a category, like what kind of, is it a feature request? Is it a bug? That kind of thing. And then we also are able to use the language model to interpret the priority of something. Is this a really big issue that needs to be addressed right now? Or is this more of a long tail, nice to have kind of thing? And then as a result, we can then automate things on the back end after for each of these classified issues. So in our case, we have a Slack bot that will come in for high priority important things and notify the right people to ultimately lead to fewer tickets, less time between when a ticket is open and when a ticket is resolved, and a better experience for everybody using Next.js. So we're going to try and recreate that a little bit here. We're going to categorize these support requests so we can do something with them afterwards. So if we had to, I'm going to be using this companion site so that I don't have to type around a ton, but instead I can walk you through everything that's going on. So this is our first experience with the AI SDK here. As we mentioned, there are 4 main functions in AI SDK core: generate text, stream text, generate object, and stream object. We're going to start off with generate text just to see how we can call the model in this more programmatic context. The first thing you do is you import generate text from the AI package. And yes, it is very cool that the AI SDK is the AI package on NPM. The first thing you have to do when using any AI SDK function is define the model and provider that you want to use. So in this case, we're going to be using the first party OpenAI provider, and we want to use OpenAI's GPT Mini. And I can actually, I can make this dark so that we're not going back and forth from light and dark. We will then pass in a prompt. So those are the 2 things that you'll need for any AI SDK function, is the model and then a prompt or messages. We'll look at a bit later. So in this case, we want the model to extract. Oh, I'm on the wrong example. That's a good start. We're actually in this classification one. So we're pulling our support requests. And then we're using generate text here. We are defining the model we want to use, passing in a prompt. In this case, we want the model to classify the following support requests. So this is, if we remember back to our prompting techniques, we're instructing the model what we want it to do. We are giving it an indication of what we want to come out. We tell it the categories or the context. The categories are billing, product issues, enterprise sales, account issues, and product feedback. We're providing 2 blank lines to separate the information. And then finally, we're simply stringifying the support requests and passing that in alongside the prompt. Very last thing that we'll do is we will log out the resulting text. So if we head back here, we copy this in, that looks a lot more as it was supposed to. And we head back to the console and we run the script again. We wait a second. So what's happening behind the scenes is all 7 of those support requests are being sent and alongside our prompt. And in this case, the model responded here, the classified support requests, account issues. I'm having trouble logging into my account, ID 1, product issues. And notice that one element that I kind of failed to include in the prompt was instruction on what kind of output we wanted. So we didn't say we want this in JSON, or we didn't say anything like that. And so the model just kind of decided whatever it felt was the best format to show these things. And in this case, this is not a format that is very useful for us to do anything with, let alone it's also not even in the right order here. For some reason, ID 3 is at the end. And then probably most frustratingly, if you've worked with language models before in the pure text capacity, is this decorating text of like, here is what you asked for, and then any notes afterwards. We could go back and update our prompt to say this is exactly the format that we want the model to return these things in, and please return only JSON. But the SDK actually has a function that is designed for generating structured data, and that's the generate object function. So with generate object, what we're going to do is we are going to change the function that we're importing from the AI SDK from generate text to generate object. We'll see that we have an error right away. And this error here is because we haven't given the model a schema, or we haven't defined what the data model that the data model that the model should generate should look like. That's not easy to say. So what we are going to do is define a schema. And in this case, we bring in one of my favorite libraries in the world called Zod. And if you haven't used Zod before, it is a library for defining data structures, maybe we could say that, with JavaScript and TypeScript. And so in this case, if you have never come across it before, the general syntax is that you import the Zod namespace, and then if you want to define an object, you would effectively access the object function on the Zod namespace. So in this case, we're defining our schema is going to be an object, or what we want the model to give us is an object that has 2 keys, request, which is a string, and category, which is an enum, and enum being a value that is restricted to only one of the following values in this array. And yeah, so what you may have noticed here is that we have moved the context of the context of the schema from the prompt into the actual structured schema here. And so in this case, we're not providing the categories up in the prompt anymore. They're down here. And with any luck, we should be good to go to run it again and see what happens. So clear the console, run the script again, and we should see we're kind of on the right path. So we've got a structured output, but it's only one of what we were looking for. And this kind of makes sense if we look back. Our schema is literally one single object, not an array of objects. So there are 2 approaches we could take to fixing this. We could add an array that wraps this object, but the AI SDK has a nice helper here called output, where we can actually specify that we want the output to be an array of whatever the schema that we've defined here. So if we were to run the script again, we're going to have to wait a little bit longer now because it's not generating just 1, it's generating 7. And we can see we now have our structured output, literally an array of JSON. And we don't have any of this here is what you're looking for. The types are nicely constrained. And to prove this to you, I can go down here and we could, for example, map through this object. So if we map through, take the elements and we look at L.category and we look at this type, we can see that this is constrained to just what our schema was defined above. This is really cool and powerful, and we're going to be building on this in a second. But what's really cool behind the scenes is that we're actually using Zod to both provide instructions to the language model, but the AI SDK under the scenes is actually parsing the model's output using that schema. So it will literally throw the equivalent of throw error, and it's a Zod parsing error if the model's output does not meet the schema. So you don't have to worry about parsing these things. Literally, if you're accessing L.category here, you know that it's going to be one of these 5 types. So this is really cool and honestly makes it feel a bit magic working with Zod and working with these language models like this. So if I jump through a few steps here, but I want to show you now what is one of my favorite, why I get so excited about working with Zod in this context. And that is because...
Before you jump into that, Nico,
of course.
I just want to take a moment here because this thing that you just showed here, it's just, as you mentioned, very magical. And I want to mention 2 things. One, going back to the question that I had for when we were trying to give the model examples, and I asked about the syntax or the proper way of providing these examples to generate the output that you like, and that maybe the traditional way was just testing and trying or using the XML approach or syntax that you mentioned. But look how easy it is now to define a schema, which then even makes your prompt so much simpler because the SDK literally takes that schema, plugs that into the prompt, and makes the model to generate the exact output that you want. So this is astronomic here for me. And then the second thing is we had TypeScript types on the returning result, so I don't have to worry about guessing what is going to be returned. I know it is going to be fit inside this criteria that I've defined. So it makes it, as you mentioned, a non-deterministic tool, very determined, very, very specific into what I can expect to get out of it. And that's amazing to me. Even without any other tool or function calling or RAG or PDF file supports, even just by building an AI chatbot or an API endpoint that I can give it information but expect a specific structure all the time is amazing.
Yeah, and to that point, those are really important things to flag because 1, we've seen our prompt become a lot simpler, but 2, as you had pointed to, it becomes a lot more declarative, which is really cool. It's kind of like we tell it what we want without telling it how to get there, and it just works. Not only that, with the parsing under the scene, we know that it's going to throw an error like you would expect any other error if an API didn't return the correct stuff. And one powerful thing that I should mention on that point, as your prompts start becoming really complex, your applications become more complicated as well. A lot of the time, when I'm just working with pure text prompts, you will add something in here like, give me, I don't know, also the urgency of each person, of each request. And your prompt starts scaling. It's like 4 or 5, 6 lines or whatever it might be. Let's say 1, 2, 3 days later, you realize you don't need the urgency of each request anymore. When it's here in text, it kind of gets lost almost within this prompt. So it could be confusing the model. It could be adding unnecessary noise to the equation. Whereas when it's here, it's literally in the TypeScript type definition of these objects. So you're getting rid of it in one place. If I don't need it in my front end, I drop it here, and now it's not in the resulting object or in my prompt either. So it becomes that source of truth in a really powerful way. And as you'll see, as you continue building with these things, these Zod types become the source of truth, both in terms of what's going to the language model, but also with how that information is going to be rendered in your front end, in your component. So I usually use these Zod schemas as like the type definition for my props that are coming in on components that I'm using, that are using the information that language models are generating. So it's a really nice a developer experience for working with this structured output with language models. But sorry, I go down the weeds with these things. I find it so cool.
Me too. Nah, it's amazing. Absolutely.
Cool. So on to the next part, which I think really like builds upon this really exciting way of building apps, which is like when we want more information or we want to expand out of our initial use case. Before we were saying we just wanted the model to categorize these support tickets. Now we want to have the model sense the urgency of these tickets. We don't amend the prompt in any way. We literally just add another key to the Zod schema of what we want. So let's copy this example and just see what happens. So in this case, all I've done here is I have copied this whole snippet and it's added this urgency key here that is an enum with either low, medium, or high. So if I save, I remember to save, and then I run the script again, we now have the model interpreting for each of these support tickets the urgency of that support ticket. Again, fully typed based on low, medium, or high. So this is really, this to me, this ability to not have to go back to your prompts every time and kind of re-architect how things are going and just literally almost defining exactly defining what it is, the data that you want the model to spit out, and it just working like that makes iterating on your prompts really fast and really a lot of fun too. And we can go further with this. We're going to, in this next part, leverage something that a lot of people forget about these language models or haven't yet discovered, in that a lot of these models are incredibly competent in other languages other than English as well. Remember, they're generalizing these patterns in language, and a lot of their training data is multilingual. And so we can import, we have another JSON file of support requests, which are these same support requests just in a different language. So we got German, Spanish, Chinese, Japanese, Italian, I think that's German again, and Spanish again. So we are going to change the import to import from this multi-language, and then we're going to iterate on our schema again to add a key called language, and that language should be of type string. So I'm going to head back to our classification file. I've just updated that, as you can see, added the language and changed the support request file we're importing. If we run this again, we will now see we have the same output as before. So account issue, we can see account in there. So it's kind of a giveaway, but we've also got the language being pulled out successfully on each of these different support tickets. But one thing that I would note here that I would not necessarily be frustrated about, but I would optimize, is that I don't want my language to be in the country code. I want my language to be in the full word. So instead of DE, I want German. Instead of ES, I want Spanish. And so we're now going to introduce you to the coolest kind of thing with Zod AI integration, which definitely was not made for this, but feels like it was made for this. And this is the describe function. So Zod has the ability to describe any one of the keys that you're using. And in this case, we use the describe key to provide the model with more context on a key level rather than necessarily on a prompt level. So what we can do here is we can say that the language string should be the language the support request in, and we leverage this idea of language models being very good at generalizing these patterns, and we literally provide an example, 2 examples of what we want. So let's copy this example in here. Run the script again, and we should see that the model has abided to exactly what we wanted. It has now returned the language in exactly the format that we want. So Spanish, German, Italian, Japanese, Chinese, Spanish, German. And so we've done this without having to modify our core prompt. We've only gone in and provided extra context on a key level. And so this is going to be one of the primitives that or one of the tips that I really want to instill in everybody using the AI SDK for structured object generation. This is really the difference between a kind of a decent output and getting exactly what you want the model to do. So yeah, that's
I
the
think it's
kind of
crazy.
the classification. Yeah, sorry, go.
I think it's crazy. This, first of all, it's crazy how these Zod APIs literally tie into what we're trying to do here. And kudos to you and the team who built this AI SDK, which literally translates this functions or this structure into the prompt that then actually makes the model to return what we want. But it's just magical to have this describe function. Like, as you were just going through that example, I was just thinking of all these different examples that you could use this describe function to really hone in on how I want this specific field now to look like. Not only I'm structuring the object and the output, but like I want to describe what do I really mean by this, so the model understands what needs to be returned here. So as you mentioned, it feels like Zod was created for this. I had the same feeling when streaming came into Next.js right at about the same time as this AI stuff, as if it was just like all coordinated at the same time to have streaming in Next.js apps, which really works well with the way that this model is returning. Now, Zod is another example of it. You feel like it is built, it's meant for this.
Yeah, and I really like I can't stress enough how powerful that tool I have to be careful with the words I use because they're duplicated across different parts of the stack, but how powerful the describe function is to getting what you want. And the last thing I would just urge people some caution on, this is obviously another point of make sure that you experiment. When we think about how do I author my schemas, particularly as it gets to complexity, I've found that I don't want to go above 5 keys. Usually I'm going to start struggling with output when I go above 5 keys. And that's when I start like breaking it down into multiple calls to the model. But just experiment with these kind of things. Like bigger models are obviously going to do better with more complex schemas. Smaller models are going to struggle in some cases with structured generation at all. Like I would say 2 billion to like 8 billion parameter models can struggle with this structured object generation. So just play around with it. The rules are being changed, not the rules, but the capabilities are improving rapidly. So something that might not work this week might work next week. So just play around.
Absolutely. I just want to touch on a few other things. You would find it in the companion site that we would include the link in the description. So there's an example for extraction where you would provide the model with a text and, for example, you want to extract some names out of it. There is summarization. We talked about the classification, and there is a section where we have different examples about building a chatbot, adding tools to it, but also talking about generative UI, which literally is another function or a kind of tool that you can call and plug in the outputs of your response or the LLM response to that specific UI that you want to create. But at the end of the day, it's a function. Maybe we would have Nico for another session. I know we want to cover Kirmase, and we want to also cover more stuff and more tools from the AI SDK. I think we are good for this session for folks to get introduced with this AI SDK if they haven't tried it before. So I'm going to include links in the description to get in touch with Nico, but also for the AI SDK and the companion site. But I think we would follow this up with more examples, maybe RAG examples, maybe uploading PDFs to really make it more useful for folks if they want to implement this inside of a website, inside of an ecosystem of APIs and applications. We would definitely provide more examples there.
Yeah, I mean, if we
notes?
if we want, we can try and do the world's fastest chatbot and try and get that in quickly. If you want, we can also save it for another session where we dive into it a little bit deeper too.
We can do the chatbot. Since that's the fastest way to build chatbots. I mean, yeah, sure, why not? Let's do that now, and then maybe we would add tools to it later on in kind of complementary videos that we do later. But now for just getting the chatbot and then maybe extending it a little bit, we can cover it now.
Yeah, we'll do that very quickly, and this is more just to show you how the context of the node-based stuff that we've done, the way that we've worked with the API, and just a pure JavaScript context transfers over to a Next.js application. So what we're going to do, I'm going to share up my window again, and I'm going to jump back to the effectively to this first to the first part of the chatbot section. So in this starter repo, we've got a directory called 5 chatbot, and in there we have a page.tsx file. And so if we run, this is a Next.js application. If we run the dev server, with pnpm run dev, I have an alias for it, so I'm so used to writing that, I forget to write it out. And if we head to localhost 3000, we should see our simple div with chatbot in here. So this is going to be our fastest way of building this. We're going to head to what is the root of the project, which is in this route group here, and we're going to type api/chat/route.ts, and this is going to be our backend for our chatbot. So what we're going to do here is we are going to go to the final example of it. We're going to import OpenAI provider as we were doing in our previous section. This time, instead of using generate text or stream or generate object, we're going to use stream text because we want to stream text. We are going to set the max duration. This is only if you're using Vercel. This is for serverless function timeouts. And on the hobby tier, you have up to 60 seconds for free. So I usually just set it to around 30. Then we pull in, because we're working with a chatbot here, we are going to pull in the messages from the request body. We then, instead of providing the model with a prompt, this time we're going to provide the model with just the messages. And what's really cool here is we don't have to do any formatting here. These are just going to be ready for the model to ingest and generate the following response. And then probably the nicest part about this is that we don't have to worry about creating a streaming response. We can literally just return with the toDataStream response function, which will prepare it for the front end to consume. So we'll paste that in. And then we are going to jump to the front end, and we're going to see the use chat hook. And I'll do this. We'll head to the page.tsx file. I'll copy this in, and we can run through things one by one. So first, because we're using a hook, we're going to set this page as a client component. If you were doing this in like a production application, you would probably move this down into its own like chat component. And then in the top level async server component, you could fetch the conversation history and so on. With use chat, we can destructure a number of really helpful things. So the use chat hook is going to manage our conversation state, and it's going to store all of this in the messages variable. So in our UI, we can literally just iterate over each of these messages. These are fully typed. And so for each message, we're going to conditionally render the role as user or AI, depending on if the role is user. And then we are going to render the content of the model's response. And then this is really, really cool. We just have a plain form component here, and the use chat hook gives us controlled inputs with input and handle input change. So you don't have to write those handlers yourself. And then it has a handle submit function that we can tie to the forms on submit, so that when you submit on this form, it will take the value of the input, send it to the language model, appended as a message within the wider message history. It will clear out the input. And then as soon as it receives the first chunk of the stream's response, it will add that to the message state so that we see it in the UI in real time as it's being received. So if I save this, we can see we've now got our input here, and I can say hello. And in a second, we will see the language model's response. So yeah, that's as quick as it is to, I think it's something like, what is it? We have styles here and a bunch of blank spaces, but that's 26 lines of code here and 16 lines of code there. Building upon those primitives, those ideas that we've been looking at earlier. And then everything that we will add in a future session, like tools, would literally be added into this stream text call here. So it's really a really powerful API that exposes complexity progressively as you need more complex or sophisticated elements to your application.
Amazing. So I wanna touch on that. A couple of things. First of all, for the chat and the chatbot that we created here, for folks who are familiar with the Next.js and all the server actions for handling form submissions, for the chat and for the streaming, we would still use the API or route handlers for the streaming functionality. So that's something to keep in mind. The second thing is, as Nico mentioned, the use chat is just a hook that takes care of all the state and the functionalities and event handlers that you would need to just hook up your form and your input. So it just makes it extremely easy. You get the state, you get the handle form submission. So it takes care of making that API call, getting the response back, updating your state automatically. And with just the simple API endpoint or the route handler that we created, which is much more simpler than the way that I had done it. I have a video on the channel where I'm going to link it in the description or somewhere in the card. You could watch it. For the most part, everything is the same. It's just that the AI SDK has gotten much more simpler. Before you had to have a couple of lines to get the streaming back to the client side, but now it's just a stream text and it's all done under the hood. Besides that, I will go deeper into how these different elements that you get back from the use hook function works. If you wanted to add more features or error handling on the other end, you can definitely have that there. It seems like I have lost connection with Nico. Let me just send a quick chat here. I think he's joining back. But yes, as I was saying, we have a video on the channel where we talk about building an AI chatbot with the same AI SDK in under 5 minutes. And we have extended this application in different forms on the video. We're going to have probably a follow-up second video with Nico where we would add tools to this chatbot, maybe the ability to add a file, maybe to add RAG, which is to provide it with some context and some data. So instead of this chatbot now responding some generic response, it just is aware of your data and your information. We can add tools to it so it can make function calls to answer specific information. As you might know, if you ask the AI chatbot now something relevant for now, it has the latest information usually these models have is for the last time they were trained on, so they don't have really real-time information. You can add tools and function calling to this chatbots or any other thing that you are creating. Therefore, you can expand the functionality of this LLMs or the chatbot to the extent that you want. I'm not sure if I can get Nico back here. It seems like we have lost the connection with him. I'm going to have to wrap this up with you guys. If you have any questions about this, or if you want me to cover anything specific in terms of this AI tools and chatbots and the SDK, if you have a specific question or a specific use case, definitely let me know down in the comments. We will all either cover it ourselves or we would have Nico to come in and help us to extend our whatever we built here. I'm going to include the links that we mentioned here for the companion site down in the description so you can follow along, and I'll see you in the next one. Bye-bye.